Just think about your day for a second. From the headphones you're probably wearing right now to the fitness tracker on your wrist, we are all living inside this invisible web of Bluetooth connections. It's this silent, amazing technology that pretty much powers our daily lives, connecting billions of devices with just a simple click. Right, we all know this symbol. It's become the universal sign for wireless freedom. But when you have billions and billions of devices all chattering away in the background, you gotta ask the question, just how safe is this technology that we depend on so much? And the scale here is just mind-boggling. A whopping 80% of all Bluetooth devices out there support what's called Bluetooth Low Energy, or BLE. That's the super efficient version that lets our smartwatches and smart home gadgets run for, months at a time. So what this means is that any little flaw in BLE doesn't just hit a few gadgets, it could affect the very core of our connected world. And that gets us right to Bluetooth's hidden danger. Because, yeah, it's super convenient, but researchers have been finding some pretty serious cracks just below the surface. And listen, this isn't just some theoretical what-if scenario. We've seen major security scares with these crazy names like Blueborn, Bluefrag, and Bleeding Bits. These have proven, without a doubt, that Bluetooth has real exploitable problems. And these aren't just minor bugs either. We're talking about flaws that can let an attacker completely crash your device, or in a worst-case scenario, even run their own malicious code right on your hardware. Yikes. So how do we find these bugs before the bad guys do? Well, one of the most powerful tools in the security toolbox is something called fuzz testing, or just fuzzing. The idea is actually pretty simple. You just throw a massive storm of broken, weird, totally random data at a system, and you see if you can make it crash. Because every single crash is like a little breadcrumb, a clue that points to a hidden weakness in the code. I love this analogy. It's like you're stress testing a bank vault. You're not just politely typing in the combination. No, you're hitting it with a sledgehammer, you're blasting it with sound, you're doing absolutely everything you can think of, not to get inside, but to figure out exactly how and where it might break. But here's the thing. While fuzzing is a fantastic idea in theory, for a long time security researchers have faced this really tough choice. A real dilemma in how to actually get it done. So you kind of had two options. On one hand, you could do it the real-world way, which is platform-based. You test the actual physical device. This gives you amazing accuracy, right? Because it's the real deal. But man, is it painfully slow and complicated. Then on the other hand, you've got the blueprint way, which is emulation-based. This is like testing a software model of the device. It's incredibly fast, you can scale it up like crazy, but the simulation is never a perfect one-to-one copy of reality, which means you could totally miss critical flaws that only show up on the real hardware. So researchers were stuck between a rock and a hard place. Do you want to be super thorough but incredibly slow? Or do you want to be lightning fast but maybe miss something important? It really seemed like you couldn't have both. Until now. And this is where we get to the BLuEMan breakthrough. A team of researchers developed a whole new framework that was designed to solve this exact problem. The big idea behind it is so elegant and honestly kind of genius. What BLuEMan does is it takes the actual real software from a device, the very same code that runs on the physical chip, and it runs that code inside a custom-built, super fast software simulator. And by doing this, it gets the absolute best of both worlds. You get the super high fidelity of testing the real thing, because it is the real code, but you also get the insane speed and scalability of the software approach. That trade-off between speed and accuracy, it's just gone. Okay, so we know what BLuEMan is. Now let's take a look at how this digital detective actually goes about hunting down these bugs. So BLuEMan basically sets itself up as a man in the middle between two simulated devices. First, it just listens in and intercepts the normal conversation between them. Second, it starts to mutate those packets. It twists them, corrupts them, and messes with them in all sorts of clever ways. Third, it fires these newly mutated packets at the target software. And finally, it just watches. It analyzes everything, keeping an eagle eye out for any crash or weird behavior that screams, "Hey, I found a bug." All right, the theory is really cool, but talk is cheap, right? What did this digital detective actually find when it was finally let loose on some real-world software? Okay, just look at this. The sheer speed is incredible. Compared to a traditional hardware-based fuzzer, BLuEMan isn't just a little bit faster.
It is a stunning 162.3 times faster. It can do in minutes what would take the old methods days to accomplish. That's a game changer.
And all that incredible speed led directly to this number. In its testing, BLuEMan uncovered 4 brand new, totally unknown security flaws in some widely used open source Bluetooth software. And we're not talking about minor little glitches here. These were serious problems, like buffer overflows and integer underflows that could crash a device from afar, and even things like race conditions that could knock a device completely offline.
So why does this all matter to you? Well, for one, these bugs were serious enough that they were assigned official CVE numbers, which is the global standard for tracking security flaws. Second, get this. 3 of the 4 could be triggered by an attacker remotely without even needing to pair with your device. But most importantly, and this is the good news, because of this research, the software developers were notified, and these security holes have now been patched, making the tech we all use every single day just that little bit safer.
So BLuEMan has made Bluetooth safer, for sure. But it leaves us with this one big thought-provoking question, doesn't it? How many other technologies that we totally take for granted, from the cars we drive to our critical infrastructure, are just sitting there, waiting for their own digital detective to come along and find the hidden flaws lurking just beneath the surface?